Welcome to lecture number 3 of this course. We now, I guess, have the followership locally at the University of Tartu, and we have a nice set of followers on YouTube of around 100 other participants from elsewhere who have decided to follow this course. I would like to welcome them as well. Lecture number 3, we are going to get into the topic of process mining itself. Today, I'm going to introduce you some of the main concepts around process mining. So you're going to see in concrete terms what is an event log, what is a process map, and we're going to talk also about the capabilities, some of the main capabilities of process mining tools, including automated process discovery, conformance checking, etc., which we will be elaborating upon in the coming weeks. With respect to the course outline, we are getting towards the middle of it. Today, I'm going to introduce broadly what is process mining about, and I'll show it to you concretely via demos that I will be conducting in the middle of the presentation. So I'll be talking for about 5 minutes, and then we'll do like a 5-minute demo. Then we'll talk for another 5-10 minutes about some other capability, and I will show you a demo, etc. You can get access to Apromore. I have either via the apromore.org website or in the Slack channel. I have given you a URL where you can go ahead, the participants in this course, and create an Apromore account and start using it. We are not going to start doing exercises about Apromore this week, but we're going to do some starting next week. Next following weeks, I'm going to elaborate on each of the capabilities that I will introduce today: automated process discovery, conformance checking, performance mining, and variant analysis. I'm going to give you very detailed guidelines as to how to conduct each of these 4 types of activities. So as a recap from lecture number 1, process mining is a self-service approach to analyzing data about a business process. And it starts with the assumption that during the execution of a business process, certain information systems are being used, like, for example, customer relationship management systems, enterprise resource planning systems, and that these systems, whenever someone interacts with them, whenever a message arrives via an electronic channel into those systems, whenever a message is sent, all of that is being recorded in the form of transactions in an information system, like a CRM. And that data, which is usually stored as records in a database, we can build extractors to go and grab them and to construct something we call, by means of some data preparation and transformation steps, we can construct something called an event log. And that's going to be the starting point of the lecture today, the event log. And with that event log, we are going to see that we can do quite a bit of analysis of our business processes and try to understand it from multiple perspectives. At the center of it all is this thing called the event log. And an event log is any table. We call it data frame in the field of data science. We can call it a table that has at least 3 columns on it. And to explain it, we have to understand what a row in this table means. So I'm going to take as an example in this table the first row, this one here. Let me take that to illustrate what it means. This row, like every other row in an event log, denotes the occurrence of an event or the start or the completion of an activity or any other state change in the execution of an activity. There are 3 columns that must be there. Every row must have a case identifier. So there is a column that tells you to which instance of the business process or in the context of which instance of the business process this activity or event happen. In this example, I am showing to you, we have an example of a loan application handling process. And in a loan application handling process, the central object is typically the loan application that a customer files in our information system. So the identifier of the process instance will be a loan application ID. Every time someone goes in the internet banking and creates a new application, clicks on the button, start a new application, a fresh identifier will be created for them. That will be their loan application ID. And that will be tagged. Every event that happens in the context of handling that loan application will be tagged by that case identifier, we call it, or loan application identifier. Every row tells us that something happens. This is captured by the activity column. For example, the first row in this data frame shows us that the customer creates that a clerk at the bank checked the completeness of a loan application to see if any documents are missing, if the correct documents were attached, if all the required information was filled in. That event where a clerk finished executing the check completeness task happened at a given point in time. So every event has a timestamp. And bear in mind that usually those timestamps have a granularity at the level of the second or even the millisecond. Here, for the purpose of simplicity, I just wrote the date, but usually you have a finer level of granularity in your information system. And these are the three columns that are compulsory: activity, timestamp, and case ID. At least one timestamp. We'll see later that if you have two timestamps, it's kind of even better, but we don't necessarily need to have two timestamps. So if we have two timestamps, like one for the start of the activity and another column that gives you the end of the activity, we can do further analysis, particularly useful when we do performance mining, but it's not a deal breaker if we do not have it, and many information systems will usually not have it. Then next to that, we have a resource. In this case, for example, that's a column that is optional in an event log, but if you have it, it helps a lot, particularly for performance mining. That's a column that tells you who in the company performed each activity. So in the first row in this table, it says that Sue, an employee called Sue, was the one who checked the completeness for application number C001 on the 18th of October. Additionally, you might have other so-called domain-specific or application-specific attributes, like, for example, since this is an event log of a loan application handling process, you will have an event corresponding to the purpose of the loan. Like, for example, was it a mortgage loan? Was it a vehicle loan, a motor vehicle loan? Is it a commercial loan, etc.? Another attribute that might make sense in this context is the requested amount of the loan, how much the customer, use this, and the offered amount. There are two types of additional attributes. Some are called case attributes and others are called event attributes. The difference is that a case attribute is an attribute that takes the same value throughout a case. To illustrate that, let me highlight that in this event log fragment of an event log I'm showing you, there are three cases: case C001, case C002, and case C003, which I have highlighted respectively just now in red. In case C001, you can see that the loan goal or the purpose of the loan is always mortgage. In this case of C002, it's car, and in C003, it is again mortgage. And the purpose of the loan does not change. It's a property that is inherent to the loan application. You cannot start a loan application for a mortgage loan and then suddenly say, hey, I don't want a mortgage anymore. I want a car instead. If you do, well, you have to start a new loan application. So the purpose of the loan does not change throughout the execution of a loan application handling process. Therefore, loan goal is what we call a case attribute. It's an attribute that remains constant throughout the execution of a case. The same might be true, we don't know, but it could be true for the requested amount. The requested amount is what the customer asks, and it might be, if I look at the entire log, that it never changes. If that is the case, I will say it's a case attribute. If I think that it can change, then it's an event attribute. In the doubt, make it an event attribute. And on the other hand, the offered amount is something that changes. Initially, this is the amount of the loan that the bank offers. Initially, it's empty. There is no offered amount because we have not yet, as a bank, made an offer to this customer. At some point in time, we offer 70,000. And it might be that the customer comes back and say, well, I do need the 80,000. So, can you make it? Maybe you make it with a higher interest rate, but can you match the 80,000? And let's say the bank comes back and say, okay, we make you an offer of 80,000 with, let's say, if you give us a second collateral, for example. So the loan, the offered amount changed from nothing to 70,000 and then to 80,000 during the execution of one case. So we will say that this thing is an event attribute. So the difference is that domain-specific attributes can be case attributes, like loan goal in this case, or event attributes, like offered amount in this case. And that is pretty much an event log. We're gonna maybe as we progress, play with some little nuances, but at the end of the day, any data frame that contains data of more or less this shape, you can say it's an event log, and you can put it into a process mining tool and start automatically or manually loaded it, and you can start analyzing it using the different capabilities of the tool. Let me illustrate this to you via a quick demonstration. So I'm going to open here the Apromore portal. Let me check that I am still in. Yes. And I'm going to upload a very simple event log. So I go to the upload button. I know that I can upload via a URL located in a remote file system or via a manual upload. And I will show you later in the process that actually a more typical way of uploading files is via the API of the tool, so that you automatically build pipelines that extract data from your CRM system, for example, pre-process them and push them into the tool. And maybe you do some transformations in the middle. And towards week number 8, we will have a lecture dedicated to data preparation and extraction, transformation, and loading. But for the time being, we're going to do manual uploads. So I'm going to be uploading here an event log that I just happen to have around, which is an event log of a process for treating patients at a hospital. It's a real-life event log with due anonymization coming from a hospital in the Netherlands, and it's for the treatment of patients that suffer of a type of disease called sepsis. The log is going to tell us what happened to those patients throughout their stay at the hospital. So I select that log. The log is initially in a comma-separated value format. I could actually open that file in Excel, and I will see a table very similar to the one that will appear just appear now in the screen. And in here, I have to indicate which column is the case identifier. In here, it was pretty obvious because the column that is the case identifier is called case ID. But there are other event logs where this label might be different, or it might come in German or in Estonian. So the tool will not be able to identify automatically that this is the case identifier column. You have to tag it explicitly using this pull down menu here. So I'm going to say this is the case identifier. This is the activity column. So you can see there are names of activities under it. And this is let me see, this is the timestamp. And in most process mining tool, the end timestamp of an event log must be there, but the start timestamp does not need to be there. So I need to at least tag one column as an end timestamp. If I don't, then the tool will not allow me to upload this event log because that's part of the minimum requirements. And there is here an attribute called org group in the original log, and that is the team that performed this activity. So we don't know who exactly did it, like which doctor or which nurse did it, but doctors and nurses in this hospital and admin staff in this hospital are divided into teams, which are called team A, B, C, D, E in this event log. And that column called org group tells me what team performed which activity. Like, for example, ER registration in this case was executed by team A. So this is what we call the resource column because it tells me who performed the activity. Other attributes can be event attributes or case attributes. I can see that, for example, this attribute infection suspected seems not to change over time. So it has a value at the start of the case and it doesn't change. So I could make it, I could tag it, if I know that is the case, I could tag it as a case attribute. The age of the patient probably does not change during a case, but I will not make a bet on it because it might be that during the course of the case, the age changes. So I'll leave it as an event attribute. And then I go through each of them and I can say, is it a case attribute or is it an event attribute? For example, this leukocytes reading, I see a column here called leukocytes. This leukocytes column is most definitely an event attribute. I can see that it goes from 9.6 to 8.7 back to 9.6 for the first case of the process, case ID number A. So I will leave it as an event attribute. There are other basics. So every column has to be, you need to tag one of the columns as case ID, one as activity, one as end timestamp. If you have a second timestamp that represents the start of the activity, you will tag it as start timestamp. You can tag a column as other timestamp. That's kind of a little bit rare, but it happens. One of the columns can be tagged as the resource, and that has a meaning. This is like who performed which activity, and others can be tagged as case attributes or event attributes. Or you can say, oh, for example, this column I don't care about, so I will just ignore it. Once you have done this, you can upload the event log and you have it in your workspace. And there you can go ahead and click on the share button and share it with one of your groups with which you work or some other username in your Apromore instance. I think I have a question. Why is it necessary to distinguish between case attributes and event attributes? We are going to see later something called filters and dashboards. And there are certain, when you define a filter, it's kind of a slightly different if you define it as an event attribute or as a case attribute. For example, let me retrieve all the patients such that leukocytes is equal to 85, right? What does that mean? Because the leukocytes reading can change during a case, I will need to specify, because it is an event attribute, I will need to clarify in the filter, do I refer that I want the cases where at least one of the leukocytes reading was 85? Or do I want to retrieve those cases where every reading of leukocytes was 85. Because it is an event attribute, the tool will need, when I define a filter over that attribute, I will need to specify whether I want to say it for all events in the case this attribute should have this value, or only for some events in the case it should have this attribute. And also for the dashboards. If the value of an attribute changes over time, types of dashboards you can construct out of it are slightly different than if an attribute value does not change over time. So it's kind of quite useful for the tool to know which attributes are case attributes and which attributes are event attributes. Some tools, and a Promore has it, under certain circumstances can automatically detect this is a case attribute or this is an event attribute, but it is kind of better if you say it and the tool checks it so that you have a full, it's all under your control, that you know what did you classify as a case attribute and what did you classify as an event attribute. So I have the event here, and then I'm gonna move to, okay, so what's next? What can I do with that log? I have a beautiful event log inside the tool of my patient treatment process. What the heck I do with it? So there are 4 things you can do in classical process mining, or tactical process mining, I call it. You can do 4 main types of operations. The first one is called automated process discovery. And this is an operation that takes input an event log, like the one I just showed you, and produces a visualization of the flows in that process, the control flows, we call it. So it discovers a process model. And in the field of process mining, we usually manipulate 2 types of visualizations. One of them is called process map, and another one is BPMN process diagrams. Process maps are usually used for high-level, quick visualizations of the process, and process models are used when you want to go further and maybe edit those process models, or you want to quantitatively analyze or simulate them, as you will see later, because BPMN diagrams have a very concrete, specific semantics that allows it to be simulated, or even to be taken into a business process execution environment where you can actually encode an executable process model and actually execute it in a business process management system. Today, I'm going to focus on the first type of visualization. And in the next 2 lessons, we are going to go into BPMN visualizations in addition to process map visualizations. So we're going to work today only with so-called process maps. A process map is a graph, and in a graph, there are boxes called nodes. Every box in a process map by default denotes an activity. So every label that you saw in the event log, like, for example, emergency room registration, emergency room triage, leukocytes treatment, all of those, every one of those labels will become a box in the process map. And an arc in a process map is a directly follows relation, or we call it a flow relation. So it tells me that a given activity happened immediately after another activity. There is an initial activity, and how do you know that this is the initial activity of the process? Is because it has an incoming dotted line coming from the start event, which is at the top of this diagram, and there are final activities. And how do you know that something can be a final activity or the last activity of at least one case? Is because it has at least a dotted line going into the end activity, end event of the process map. So here, the activity at the bottom, which has a dotted line going into the end event, is a final activity. And every arc in the process map is annotated with some performance measure. And by default, in a process map, the performance measure that is displayed is called the case frequency, which is the number of cases where an activity occurred, or in the case of a directly follows relation of an arc, is the number of cases where these two activities, the one before and after the arc, were executed consecutively, one right after the other. In how many cases did it happen? That's what it means, the case frequency of an arc. But we will see that you can change that performance metric, and sometimes it is useful to change the performance metric that you display or that you overlay on top of a process map. So before I show you the process map of this running example, the sepsis treatment event log, I will tell you two operations that you can do on a process map or an event log in order to simplify it. And that is going to be very necessary because real life business processes are very messy. You cannot attempt to try to understand every possible pathway in a real life process. You have to simplify it. And process mining gives you two types of tools or operations to simplify your process diagrams, your process maps in particular, so that you can better understand them. And these mechanisms are called abstraction, number one, and filtering, number two. Abstraction is like a visual simplification mechanism. Abstraction means that I'm gonna hide some of the arcs or some of the activities in the process map in order to make the process map more understandable, so that instead of having a spaghetti like the one you see at the top, you have an enchilada, if you want, the one that you see at the bottom, but that is a little bit more understandable. And which arcs you hide? Well, you can tell to the process mining tool, please hide me the most infrequent activities or the most infrequent arcs, or the fastest arcs. I'm into finding bottlenecks, long waiting times. So I don't care about the transitions that happen fast. I only care about those who happen slow. So please hide to me all these transitions that are happening fast and keep only those that are happening slower. So you have a bunch of options as to what can you hide out of a process map when you abstract it. Abstraction is nice, but it doesn't really solve all your problems. It can still be, because it's a trade-off. The more you abstract, the simpler your process map looks like, but the more details you have lost about certain behaviors that are happening in your process. So trying to improve on the basis of a highly abstracted process map can be misleading because you are not seeing everything that is happening. So an alternative mechanism to simplify, to get simpler process models or process maps, is by means of filters on the event log. And a process mining tool will incorporate a library of different types of filters, like, for example, attribute filters that allows you to, filter out some activities out of your event log. For example, there are some types of steps in my process, like administrative steps such as billings and payments, which are there in my event log, but I don't care about. So I'm going to remove them. Or I'm going to say, let me remove those cases where, let me retain only those cases that involved a leukocytes treatment. I'm not interested in those ones where no leukocytes treatment happened. I'm only interested in one where there was a leukocytes test. So you can define a filter on your event log that retains only those cases where a leukocytes happen and deletes all the other cases. Or cases where a blood treatment happened, or cases where the patient was diagnosed with COVID. And you can extract only those cases and get rid of those ones where the patient was not diagnosed with COVID. Then you can discover a process model out of the filter log only with the patients that suffer from COVID. And naturally, you will get a simpler process map than if you try to derive the process map from all the cases, COVID and non-COVID patients. And in some cases, that is useful because you might only want to improve the flow for patients with COVID at this particular point in time. There is also a performance filters that allows us to say, I'm going to retain only those cases that in total took more than 2 hours, or where the waiting time was more than an hour. So that can be very useful, for example, to find treatments, patients that are spending more time than we will expect them. And there are other types of filters, including path filters, that allows me to retain only cases where a given activity happened and later another activity happened, as well as repetition filters, which allows me to retain those cases where, for example, a patient underwent a surgery 3 times, which is a very special circumstance and is worth investigating. So I can take the log and extract a subset of it only with a subset of cases in order to further investigate it. And that gives me a way of simplifying the maps that I am extracting from my business process. So let me move into demo to make these concepts very concrete. So I had just now imported this sepsis event log. From it, I can discover a process map. In a promoted, the simplest way of discovering a process map is just by double-clicking on the event log. So then I get an automatically discovered process map. So as I announced, a process map consists of boxes that corresponds to activities. In this case, this is an activity called emergency room registration. This is an activity called emergency room triage, emergency room sepsis triage. This is a start activity. I know it because it has a dotted line coming into it, coming from the start event. And somewhere here on the right-hand side, I can see the end event, and this is an end activity, but release B, release C, release D are also end activities. Every node is annotated with the number of activities, of the number of cases where this happened. So in 1,050 cases, I saw the activity emergency room registration. And in total, there are actually 1,050 cases. So in every case, I saw this activity. In all cases, 1,050, I saw emergency room triage, but only in 1,049 cases, I saw an emergency room sepsis triage, which means there was one case where this didn't happen. And this only happened in 753 cases out of 1,050. Similarly, the edges denote the number of cases where emergency room registration was immediately followed by emergency room triage. This sequence of activities happened in 971 cases out of 1,050. And now you will ask me, so Marlon, what happened to the other, 84, 89 cases? Where did they go? This process map is not settings. You can see that the arcs, there are 2 sliders. The arc slider is the node slider is 100%, which means that the process map that is being displayed contains all the activities that are in this log. But the arc slider is only at 10%, which means that only a subset of the activities are being displayed. So if I wanted to see the whole process map, I will have to drag the arc slider to 100%. And this is what happens. Real life processes are messy and you cannot comprehend them at once. So you usually on an entire event log, say of 2 years of a given business process, you won't be able to see everything. And that's why you need to abstract, which is what you achieve by bringing these sliders down to a reasonable level where you can still understand what is happening, but not too much, so that you don't get lost in details. So we'll leave it at that. And we'll see next week's how you can further simplify this process by using BPMN notation instead of process maps. But for the time being, we're going to leave it at that. By the way, you can abstract in different ways. You can abstract also by duration. And in this case, and you can click here on invert ordering. And in this case, you can say, let me remove the fastest cases, the fastest arcs, the arcs that have the smallest durations, and let me keep the ones that have the highest durations. And we'll see that how this can be useful when we are finding bottlenecks when we get to the topic of performance mining. Finally, as I told you, you can also filter. You can also use filters to simplify your process map. So let me go back to the case frequency and let me put back things in the normal order. So, and let me see what do we mean by filters. So I click on this icon in the ribbon, which looks like a filter, like a engine filter. And I see that there are a number of different types of filters. I'm going to explain this at length as we move along, but the ones I mentioned in my slides were the attribute filter, which allows me, for example, to retain those cases where an activity with a certain label occurred. So for example, I can say, let me retain those cases where an IV antibiotics, an intravenous antibiotics treatment was applied. I'm not interested in those that do not have intravenous antibiotics for the purposes of my analysis. So I can select retain all cases where IV antibiotics happen. And I could add even like a second condition on those attributes. And I'll say, and for example, this treatment, IV antibiotics, is performed by team A and team L. I might only be interested in those cases where intravenous antibiotics happen. So that's the primary condition. And as a secondary condition, I want to retain only those cases where team L executed this activity where IV antibiotics happen. So I apply these, and the tool tells me that 4.3% of cases fulfill my criterion. And then I can apply this filter, and immediately the process map is refreshed, and I get something a little bit simpler than before. With a bit of luck, I cannot get to 100% of abstraction, but I can get somewhere around 60% of arc abstraction, which means that by focusing on this subset of cases, I am able to explore more details about those cases, not about the whole process, but about those cases. And there are other types of filters. We mentioned, for example, the case duration or performance filter, which you will find by exploring through the list of available filters. So I can delete this filter, and I instead create a different filter, for example, performance filter, and I can retain, for example, only those cases that took more than 1 month. I apply that, and I see that I retain only 204 cases out of 1,100. By the way, if I click on the number of cases, I can also explore the process case by case if you wish. Okay. So that's what I wanted to say about, give you a hint or a touch of what automated process discovery means. It's about discovering visualizations, diagrammatic visualizations that allow you to understand a process out of an event log. All these visualizations were done starting only from the event log. The second capability of process mining is so-called conformance checking, or sometimes also called conformance analysis or compliance analysis. Conformance checking techniques take as input an event log, like all other process mining techniques, so the event log at the center, and either as a process model, but more often a set of business rules that should be fulfilled by the event log. So, for example, I could take a simple like the process model saying, this is how this process is supposed to be executed. And from the event log, I can calculate the actual process that is being executed. And by comparing the two, I can somehow find some insights into the deviations, to what extent the reality recorded in the event log deviates with respect to the norm, the process model that captures the expected pathways in the process, or maybe the normative pathways in the process. Sometimes for conformance checking, I take as input like a normative process. In most cases, this is unrealistic because there is not like one normative process out there. There are actually multiple different ways of performing this process. So it is actually much more common to do conformance checking by means of rules. So you will say there are certain compliance rules that we need to satisfy. Like, for example, certain activities like emergency room registration must be performed for every case. Or some activities like intravenous liquid must not occur multiple times in the same case. Or I can say things like, for example, between the moment the patient checks in into the emergency room and the moment I have classified that patient into one of different categories, no more than 2 hours should elapse. So different process mining tools will offer you different capabilities in terms of being able to check that the reality, the event log, the process is following certain compliance rules or is abiding to a certain normative process model or not. Just to give you a taste of how this could be done, for example, I can go back, delete all the filters here, and define a filter, namely a path filter, to capture a compliance rule. So I'm gonna write a filter that captures the compliance rule, and using that filter, I'm gonna retrieve if there are any cases that are not fulfilling this compliance rule, and that will allow me to investigate those cases. For example, one possible compliance rule is that after emergency room registration, left-hand side, eventually, not immediately right after, but eventually, the patient must be classified. So an emergency room triage activity should happen. And I'm gonna say that this activity must happen within 1 hour. So I'm gonna put an upper bound to the distance, the time difference between emergency room triage happening and emergency room registration happening. The difference must be less than or equal to 2 hours, let's say. This is my compliance rule. For every patient between emergency room registration and emergency room triage, no more than 2 hours should elapse. The time difference should be at most 2 hours. So to check this compliance rule, I will remove those cases that are compliant, that satisfy the rule, and hence I'm only going to retain cases that are not compliant. So let me apply this rule, and I get that, hey, there are 6 cases among the 1,050 that do not satisfy this rule. After removing the cases that satisfy the rule, I was left with these 6 cases. So I can click OK, and I can see what is going on in these cases. I can here select one of those cases and see what happens and see, well, indeed, between emergency room triage of this patient with case ID IC and emergency room registration, 3 hours and a half elapsed. And there are many things that you can do with a path filter in terms of compliance checking, or with other types of filters like repetition filters and attribute filters. And we're going to have an entire session in about 2 lessons time dedicated to seeing what kind of compliance rules can you check using different types of filters on your event log. So, and by the way, every one of the filters I define, when I define it, I can save it. There is a button for saving it. And you can define a set of filters, each of which corresponds to a compliance rule. And therefore, at any point in time, you can go and replay those filters to retrieve any cases that have violated your compliance rule. The third capability of process mining is so-called performance mining or process performance mining. Process mining gives you the ability to visualize the performance of the process in terms of a number of performance measures, such as the one we saw last week, case frequency, we talked about cycle time, waiting times, processing times, costs, if you have cost information in your event log, or you add it into the event log in some way. You can also reason in terms of cost metrics, in terms of defect metrics, if you have that information available in your event log. And you can understand the performance of the process in terms of those performance metrics, and also drill down to try to figure out which activities or which flows in the process are contributing, for example, to high waiting times or to high processing times. There are usually three or more ways in which process mining tools will help you to do performance mining. One of them is by means of dashboards that display a number of performance indicators, as well as charts like distribution charts or maybe cross-sectional charts to understand the performance of your process from different angles. There is also another approach, which is by taking the same process map or BPMN model that we mentioned before and overlaying on top of it a performance measure, for example, processing times or waiting times. And finally, there is a feature we will see a little bit later, which is called log animation, where I can take a model or a process map and a log, and I can replay the log through the process map to see where the bottlenecks build up. Let me have a quick demo of that. So I am, at the moment, I'm going to remove all these filters I have placed, and I'm going to try to bring my process map to a reasonable level of abstraction. And at any point in time, I can change the metric that is displayed on top of the process map. By default, I display the case frequency, but I can display different other types of frequency metrics, like the relative case frequency, which gives me percentages. This is very useful, for example, to understand after EF sepsis triage, in what percentage of cases I do IV liquid versus in what percentage of cases I do leukocytes. And you can display the total amount of times that an activity was performed. Hey, ER sepsis triage was executed 1,053 times, but there are only 1,050 cases in this process. So what can that mean? Well, it probably means that there are 3 cases where this activity is performed twice instead of once, which is weird. And I might want to go and do a filter to have a look at those particular cases where this is happening. You can change the frequency to max frequency, and that tells you that indeed there are cases where ER triage occurs twice. So the maximal number of occurrences of ER triage in a case is 2, whereas ER sepsis triage occurs at most once per case. There is no case where emergency room sepsis triage is occurring more than once. And you can select the minimum frequency, and this will tell you if there is any activity that did not occur at all. So for example, there are cases where ER sepsis triage does not occur. Its minimum frequency in a case is 0. And you can click here on the duration overlay, and you can see instead of frequencies, you will see durations. For example, between emergency room registration and emergency room triage, I see that about 11 minutes elapse. By default, this is the average time, but it could be, you can make it the median, or you can make it the total. And the total gives you a good idea about, like, cumulatively across all these 1,050 cases, if I stack up all the waiting times between ER, emergency room registration, and emergency room triage, and I stack them out, it will give me 1.02 weeks of waiting time between the moment I finish the registration and the moment I finish the emergency room triage. And you can change the aggregation metric, the maximum duration, the minimum duration between these activities. Now, you will notice that inside every box, there is the word instant, which means 0 seconds, if you wish. And that means that the process mining tool is unable to calculate the processing time of the activity. It can only calculate the time between the end of an activity and the start and the end of the next activity. Why? Because my event log initially only had end timestamps. And if I only know the end of every activity and not the start time, I cannot tell you how much time my workers spend doing the activity because I don't know when they started. All I can tell you is the time between the moment one worker finished one activity and the time when the other workers finish the next activity, i.e. the cycle time of the second activity. But I cannot tell you anything about the processing times, the actual amount of time spent by workers. If you have an event log that does have a start and end timestamps, and I'm going to show you one right away, this one does. So this is an event log of a repair process. People call in because my video projector broke in my lecture room. Can you come and fix it? And then the technician is called and they try to fix the video projector or the audiovisual equipment or the camera, etc. in the room. And in this process, there is start timestamp and there is end timestamp for every activity in the process. And thanks to that, when I go to the duration overlay, I will be able to see both the processing times. For example, the average processing time of analyzed defect is 7.5 minutes, and the waiting times, the time between the moment analyzed defect finished and the moment the repair started was 14 minutes. So someone came, looked at the video projector, maybe they left, and they came back, and 14 minutes later, on average, they were starting to repair the video projector in my room. And it takes them, on average, 23 minutes when it is a complex repair. This kind of visualization with duration overlays are pretty good at spotting what are the bottlenecks in my process. But there are other types of analysis I can do, as we will see in 3 weeks' time when we dive deep into the topic of performance mining. You can also do something else with this type of event logs. You can open them in a dashboard, and any process mining tool will allow you to create some dashboards out of your event log. And the dashboard will display a number of performance measures and performance charts and performance tables that you can later customize, as we will see. So, for example, this dashboard here contains a chart, contains a card here that tells me that the case duration is on average 1.1 hours, the median is 1.02 hours, the minimum is 9 minutes. There is a chart with the cases over time, which tells me how many active cases there were over time. And I can see that the peak was on the 11th of January, where there were 7 active repair cases happening in the same day or being active on that particular date and time. You also have these charts that give you information about the distribution of frequencies of different activities, and you can customize such performance dashboards to build different types of distribution charts or cross-sectional charts or longitudinal charts, or charts that have the time in the x-axis. And finally, but I'm not going to show it right now, you can also take this process map and we can animate it, which means we will see tokens circulating through the different tasks in this process. This is something we will kind of have a look at a little bit later, but we are not going to do it today. And this is kind of useful when you want to visualize bottlenecks, but not statically, not over the whole duration of the period of time I observe in the event log, but bottlenecks at different points in time, like bottlenecks in January compared to bottlenecks in February or in March or in April. Bottlenecks can be located in different places, and animation will be able to replay the log like day by day, month by month, and to see how these bottlenecks are evolving over time. Finally, the fourth capability that process mining brings you into the table in terms of analytics is what we call variant analysis. And by far, this is the practically most useful of them all. Variant analysis means the ability to compare multiple subsets of cases of the processes. We are going to call them multiple variants of the process. So the input of variant analysis is 2 event logs or more. It can be 3, 4, 5, but in any case, multiple event logs. One event log may be all the cases that happen in Estonia. The other event log, all the cases that happen in Latvia. Or if you have 2 wards in your clinic, in your hospital, all the cases that happen in ward number 1 and all the cases that happen in ward number 2. And the purpose of variant analysis, also called variant comparison, is to compare these 2 variants of the process, for example, in 2 different countries, in order to identify the difference. And this is highly interesting because as a business manager, a business analyst, typical questions you have are like, why are we performing better in the Tallinn branch versus the Tartu branch? Or why are we performing better in Estonia versus Latvia, or vice versa? Because by identifying those differences, you can get some hints into how you can make the process for some of your cases better. How can you improve? And ultimately, that's what we want out of a process mining analysis. So, for example, using these variant analysis techniques, we will be able to compare the cases that go fast versus the cases that go slow. And we'll be able to see things like, for example, hey, in the cases that go slow, there is some rework loop here that doesn't occur in the cases that go fast. And that's going to tell me a lot about like where are the sources of defects in my process that are causing me long cycle times. You can do variant analysis using similar techniques as performance mining, except that instead of taking one log as input, you take multiple logs as input. And so you can use, for example, comparative charts, where you construct a performance dashboard that takes two logs as input, one, let's say, in red and the other one in blue, and allows them to compare the process from the performance measurement perspective from different perspectives. So to illustrate that, I'm gonna show you how I will do a variant analysis in this process. So one thing I can do is to take, for example, all the cases where the case duration is less than 30 days. This is about 20% of cases, I'm told here on this bar chart. And I can save those ones. And I can say that these are, there's a button for saving the filter log in the ribbon. And I can say these are the fast cases, or the cases where the performance is satisfactory. And then I can go to the filter and do the opposite. Edit this filter. Instead of retaining those cases that take more than 30 days, I want to remove those cases that take more than 30 days. So I get the ones that take less than 30 days. In fact, now that I think about it, these are the fast cases. And the other ones that I say before were the slow cases, because more durations means slow. I made a mistake just a minute ago. So to correct that mistake, I might rename this event log into slow. Okay. So now I have two event logs, and I can select both event logs, and I can ask the tool to construct a single performance dashboard, a comparative performance dashboard out of the two event logs. And then I can see things like, for example, good to put this in relative scale always because of the difference. I can see, for example, that there were more blue cases like in July in relative terms. I changed the scale here to relative, so it's all relative to the total number of cases in each category. So there were more cases in that were slow in this period than there were fast cases. Specifically, there was a period around July where there were relatively very few fast cases. So that indicates I might have a problem here in July. I can also go to other types of charts and build additional charts. Always good when you compare to put them in relative scale. And I can see, for example, that relatively, and this is after normalization, for example, admission into intensive care happens more often for the slow cases than it happens for the fast cases, as I would expect. So if a patient goes into intensive care, then the duration of their treatment is going to be longer than if they do not go into intensive care. So that's a pretty obvious finding, but you will see other examples where we can find some non-trivial findings, like, for example, the fact that a certain activity gets repeated multiple times contributes to a case being late by X amount of days. So let me, and I can do, I can also, these two event logs that I put here, I can also do other things with it. I can do like side-by-side comparison, for example, of the cases that like I open in one window the slow cases, and I open in the other window the fast cases, and maybe, so I have fast on the left, slow on the right, and maybe I lay them out vertically. There is a way of turning the layout in vertical, and I put the case duration, and I can see, for example, some differences between the two, for example, in the fast cases, the average time between IV antibiotics, in the slow cases, the average time between intravenous antibiotics and admission IC is 41 minutes, whereas in the fast cases, this difference is 1 hour. So I can start kind of seeing some differences. Maybe a more striking one comes from these lactic acids, which seems to occur more often in the slow cases than in the fast cases. I cannot see it actually in the fast cases. So that gives you some insights into like activities that happen when slow cases that don't happen in fast cases, or that happen at different points in the process with respect to the fast cases. That gives some hints as to what can be causing delays in a business process. So to summarize, we have gone, like taking a very small tour through the 4 capabilities of process mining: automated process discovery, like discovering process maps from an event log or process models; conformance checking, so checking the compliance of a process against certain normative processes or compliance rules; variant analysis; and performance mining, as explained in here. And what's next? Well, next week, we will dive respectively into each of these 4 capabilities. First, automated process discovery, conformance checking, etc. And for every one of these capabilities, I'm going to present you around 4 types of business questions, typical business questions that you might ask in the context of automated process discovery, the context of conformance checking, performance mining, etc., and what sequences of process mining operations you can use to analyze it. In other words, I'll give you like a workflow of how you can analyze a business process through these different 4 stages. This week, we are not going to have a practice lesson, but next week we will resume with the practice lessons, the practical lessons after the lecture, or following the lecture. And I would like you to be prepared to do some exercises. So please create an Apromore account. It takes about 2-3 minutes, and be ready to start. I'll be giving you some event logs, and we'll start loading them and start playing around with the data starting from next week. If you have any questions at this stage? Right. So far, so good. The introductory part of the course is completed. I give an overview of what this is about, what are business processes, what is process performance measurement, what types of measures there are, what is process mining, what is an event log, and what can you do with an event log. And from next week, we're going to start the practical part, and I'm going to start releasing the homeworks, starting with the homework I will release next week. And I'll be releasing homeworks roughly at a rate of 1 every 2 weeks thereafter, or 2 to 3 weeks thereafter.